Dude, what was in that release? Production just went down.
I don't know, it's just that code you had me working on.
Did you test it? Because you just took prod
Yeah,
down.
I tested it. Look, I can show you right here that it works.
Okay, it might work there, but it's not working on prod.
I don't know, dude. It works on my machine. You know, it actually kind of sounds like you've got a production issue. Maybe you should just check out this cool video I watched, and it tells you the 5 steps for dealing with production outages.
Unfucking believable.
What? Trying to help. Hey, so if you've been writing software for any length of time at all, you've probably without a doubt deployed code to production that didn't do what it was doing on your local workstation, maybe even took production out entirely as well. If you're just getting started writing code, don't worry, your day is coming. It's gonna happen. But when it does, bookmark this video, come back and leave us a comment so we can all have a laugh about it. And don't really sweat it too much. It happens to all of us. And to be honest, it's kind of like a badge of honor. So in today's video though, I'm going to show you some tips and tricks that I use to make sure that my local development environment matches what's going to be happening in production as closely as possible to minimize scenarios like that happening. So I think this is one of the areas where Docker actually really shines in its ability to reproduce locally what's going to be happening out in production, because I can run and build locally using the exact same Docker image that I'm going to be using out in production. And I'm going to show you how to set that up and how I do it. Now, if you're doing something like using serverless in AWS, the serverless framework's a really great tool for helping you out there, because when you're going to that serverless route, you're dependent on a lot of applications provided by AWS and other providers. And so you either need to have those running locally that you can interact with them when you're developing, interact with them out on the third-party cloud, wherever they happen to be in a test mode or a development type environment, or mock the dependencies within your code itself. And really, whenever it comes to mocking, the hard part about mocking is you can only mock the things that you know about that response, which gets really, really tricky. So the ability to run that locally is a huge advantage, and that's where the serverless framework can help you out there. And I'll put a link down to the serverless framework in the description below, so if you're not familiar with it, you can check it out there. Now, if you're using Kubernetes in production, there's a strong argument to be made that you should probably be running Kubernetes locally. And a lot of that has to do with how tightly integrated your application is with the orchestration services that Kubernetes provides. It's one of the reasons why I actually have this computer running back here is for that exact environment. And so if you've ever really wondered about when the computers will take over and start killing the human race, I'm going to be the first one that they kill because of things I do like that. So if for no other reason, actually, that's a great reason to subscribe to the channel. So you know that when I stop posting videos, it could be a really early indicator that the end of times are here. So, do yourself and your family a favor and just click the subscribe button. Okay, so let's take a look at how I actually develop locally in a way that mimics what's going to happen in production. And the first thing we're going to take a look here is at my Dockerfile. So right away we can see in my Dockerfile that I'm using the base image node 14.15 that's built off of the Alpine 3.12 image. And that's the exact image that I use out in production. So then if we scroll down here a little bit, you can see that whenever this Docker image gets built, I copy the Package.json over from my application, run npm install so that anything specified as a dependency in Package.json gets installed in that Docker container. And that also has the added benefit of if I add a package but don't save it to Package.json, whenever I'm developing locally, that's going to cause that to show up as a missing dependency, which prevents my application from running. So I will identify that before it ever leaves my workstation. And then I'm also exposing port 3000 down here. That's the port that my Express application is running on, and exposing port 9229, which is the Node.js debug port, so that I can debug my application locally while it's inside that Docker container as well. And then finally, I'm running the command when this container starts, npm run dev. So if we take a look at that over in Package.json, all npm run dev does is it sets my node environment, sets the log level, and then runs the application nodemon. And nodemon is the application that's actually looking for changes to the file system and restarts the node service when that happens. All right, so to get that part working though, we're going to take a look at the Docker Compose file here. And so Docker Compose is a way for me to specify multiple Docker containers that run as part of the overall application. So I've got my Node.js Express application here. I've also got a database application that's running Postgres 12.1, and I've got Elasticsearch running here because that's used by my application as well. And so all of those will be brought up within the same network inside of Docker and have the ability to communicate with each other just like it's going to happen out in production. So now the magic that makes all of this work comes in this volumes declaration right here, because you can see here that I'm mounting the current directory into the Docker container in a folder called app. And if we take a look at the current directory, so it has my app.js file here, and then my public folder, my routes, and my views, everything that makes up my application. And this is where I'll actually be writing my code for the application. So that gets mounted inside the Docker container, so that shows up as a file system in the Docker container. And then we launch the application using nodemon. So when nodemon sees me change those files here in my local editor, they'll show up as changes inside the Docker container, which will cause nodemon to reload my Docker application or my Express application in that container. So to pull all that together, I use Makefiles. And so Makefiles actually come from way back in writing C code days, but they contain a lot of cool features that really help me out here. So I create a make command called devup that runs the Docker Compose command, specifies the path to my Docker Compose file, and then the up argument to it so that it brings everything up. So now all I have to do is click this arrow, and that launches my Makefile or my make command, and that's going to bring everything up. So now if you don't actually use WebStorm, which is what I'm using here, you're not going to have the little green arrow here. So the easiest way to resolve that is to go to JetBrains website and download WebStorm, which is kind of funny, but it's not really funny if you don't have WebStorm. So the other thing you can do, which is why I like Makefiles, is you can just open up a terminal in the directory that you're working and type make devup, and that's going to launch it as well. The make command itself is an older Unix command. So it's available on Unix, Linux, OS X. I don't know if you're using Windows, if Makefiles or Make is available on Windows. I know in the last few years they've done a lot of work to support Unix and Linux type stuff inside of Windows. So there's probably some kind of way to run it, but I don't use Windows, so I don't actually know what the answer to that question is. But anyway, going back over to this, you can see that it launched everything and ran it. Same thing over here where I launched it the first time. And this is this command, you can run it as many times as you want. If everything is already up, it just looks and says, hey, everything's up, we're good, don't worry about it. But if one of your containers has crashed, it will bring it back up and bring your Docker environment to the state that you want it. So if I switch over to my services tab here, I can go into my Docker environment. And again, if you're not using WebStorm, you can get to this by typing Docker PS. So I called my application node with Docker, so I expand that. Here are the 3 Docker containers that we specified in that Docker Compose file. If I expand the Express container, I see the logs. And to replicate this without WebStorm locally, again, you would open the terminal and you would type docker logs express, which is the name of the container, because we specified that container name here in our Docker Compose file. And now if I go back over to the terminal here, I can do curl localhost 3000, and we get our HTML response which says welcome to Express with Docker. Now here comes the cool part. You ready? Watch this. I'll go over to my index file and I can change my title here. And now when that saves, if we go back down here to our services, you can see right here, nodemon picked up the changes, restarted my container. Go over to my terminal here, run that exact same command, curl localhost, and here are the changes that I made. And now that's all running inside of Docker. Nothing's running on my local application or my local workstation. And it's using this Docker image that I'm going to be using out in production. So now I know that because I installed my dependencies inside that Docker container, I know I've got my dependencies set. I know that everything I'm doing is compatible with the flavor of Linux that I'm running my Docker images on production in. And I've eliminated quite a few different places where I could be doing something locally that's not contained in my code or in my application that would cause production issues. Yeah, I know. I was just bitching about using Node.js in one of my other videos, and here I am showing you a demo with it, but sometimes we got to play the hand that we're dealt, and this was the hand I was dealt today. So there you go. So now the example I just showed you was using Node.js and nodemon for the hot reloading. But really, whether you're using Go, Ruby on Rails, or Python or whatever, you know, there's almost all of them have some type of hot reloading mechanism that will reload the application or reload the service once you make changes to the file system. And so the key to making that work is just that you mount your application directory, your local file system where you're writing your code, as a volume in the Docker container. And then your start command for the Docker image or the Docker container is the command that's going to force it to look at the file system and reload your server when it sees file changes on that. So there's other things we can do to make our local development environment look closer to production, and I'll cover those in some upcoming videos. So if you like this video, hit the like button, leave me any comments that you have down below. And if you want to see the rest of those videos and the other videos whenever I publish them, be sure and hit the subscribe button down below and turn on or enable notifications so you get notified when those videos come out. Thanks, and I'll see you next time.